2.3, product and quotient rule. So a product is when you do what? When you multiply. And so when I take a derivative with two things being multiplied, two functions being multiplied together, this is the way we do it. I kind of differ from the book a little bit here. And so I'm going to say the derivative of the first times the second plus the derivative of the second times the first. Okay, and so that's how we do the product rule. It's the derivative of the first times the second plus the derivative of the second times the first. So I have this function h of x is equal to the quantity of 3x minus 2x squared times the quantity of 5 plus 4x. And so I have two functions basically being multiplied together. Now, on this one particularly, could we do algebra first and then do calculus? Could we actually FOIL this out and do it that way?
Yeah.
Yes, and I'm actually going to prove that to you on the end. However, sometimes we need to use product rule, and I'll show you on the next set of slides as well. All right, but this one actually doesn't need product rule, but we're going to use it because that's today's lesson. Okay, here we go. So, h prime. So how do I do h prime? The derivative of the what? The first. So what's the derivative of the first?
Negative 4x plus 3.
Okay, 3 minus 4x, or negative 4x plus 3 if you wanted to redo it that way. And then times the second. It's not the derivative of the second, it is just times the second. And then plus. Now we take the derivative of the second. So what's the derivative of the second? 4. And then times the first. And so right there was calculus. This is called a raw derivative. All right. And so the rest of it is going to be algebra. All right. And so now we have to simplify. And a lot of the times the algebra is the hard part. And so h prime is equal to, we're going to FOIL this. So what do we get? Okay, 15. Sure. 15 and then what?
12x plus 1x. And then
So 12x and then
minus 20x.
minus 20x and then minus 16x squared. And then what are we going to do with that 4?
4. Multiply.
We're going to distribute it. So then we have how many x's?
12.
12x and then minus 8x squared. All right. And so now, let's combine like terms. So now let's combine like terms. So h prime, do we have any buddies with x squared? Yeah, what do we get now? Negative 24 x squared. And then how many x's do we have?
So let's see, so 12, so 4.
We have 4 x's. Good. All right, so now we have plus 4x. And then do we have any constants? Yes, so we get 15. All right, and so that was how we found h prime. And so again, what is h prime? It's a derivative. What's a derivative? Slope of a tangent line. All right, but before I do that, I'm actually going to prove to you why this product rule works. I'm going to actually FOIL this first part. Okay, so I'm just going to manipulate h of x. So now I'm going to FOIL this first part. Okay, so I'm going to take what we originally started with, and we're going to just like simplify it first and then take a derivative. All right, because we can actually do that this time. So what's my first? 15x. And then what's my outer? 12x squared. And then my inner? Negative 10x squared. And then my last is plus, minus 8x cubed. All right. And so now if I simplify that up a little bit, we'd have h of x is equal to negative 8x cubed. And then how many do I have? Plus 2x squared. And then plus 15x. All right. So actually algebra was pretty easy on that one. And then let's take a derivative. So h prime would be equal to what? Negative 24x squared and then plus 4x and then plus 15. Well, looky there. All right, they're the same. Okay. All right, so now we're going to find derivatives on this one. So now I have y equals 3x squared sine x. And so on this one, we have to use product rule. All right. There's no other way we can do it. We have to use this new rule, this new tool in our toolbox. All right. And so what is my first? Let's talk about first and second on our product here. So what's my first function? 3x squared. My second function is sine x. Make sense? All right. So here we go. How do I notate taking a derivative of y? dy dx. Very nice. All right. And so then how do I do product rule? The derivative of which one? The first. So what's the derivative of my first? 6x. And then what? Times sine x, times the second. And then plus, now the derivative of what? The second. So what's the derivative of the second? It's not negative, it's cosine. And then times the first, which is 3x squared. All right. Now, you can technically simplify this a little bit. We could factor out a 3x from both of them. And so dy dx would equal 3x times 2 sine x plus x cosine x. So you could factor out something there, but I don't think it's that useful to do it on that one. All right. All right, let's look at the next example. So now I have y equals 2x cosine x minus 2 sine x. So on this one, you'll notice that this part, this 2x cosine x, is being multiplied together. So what's my first on that? 2x, and then my second is cosine x. This is actually just like the constant multiple rule. All right, this negative 2 sine x. This is not a product necessarily because I don't have a function, it's just a number. Does this make sense here? All right, so I don't want you to think that everything being multiplied is always a product rule. All right, Yamil, how the heck do I notate taking a derivative? Gosh, this guy's good. All right, so I got dy dx is equal to what? How do I do the product rule? The derivative of the what? The first, which is 2. And then times what? Cosine x. And then plus or minus? Plus. Plus. And then the derivative of what? The second. What is the derivative of the second? Negative sine. Very good. The derivative of cosine is negative sine. And then times 2x. And then, so that's the product rule. Now I need to take the derivative of negative 2 sine x. So what's the derivative of negative 2 sine x? Negative 2 cosine x. Okay? So now, does anything lovely happen?
Looks like we have 2 cosines minus
The cosines cancel. The 2 cosines cancel. So now those cancel. And then I'm left with that term right there. And so dy dx is equal to negative 2x sine x. So we just talked about product rule. So the product rule is the derivative of the what? First times the second plus the derivative of the second times the first. All right. So now we're going to talk about the quotient rule. All right. And so the quotient rule is when we have a quotient. All right. So we got derivative of a function that has a numerator and denominator. Now, again, I think the book does it backwards. So here we go. So what we're going to do is we're going to take the derivative of the top times the bottom, and then minus the derivative of the bottom times the top all over the bottom squared. All right. All right, so I have this function y equals 5x minus 2 divided by the quantity of x squared plus 1. So again, I have a binomial on the denominator. I have to use this quotient rule, or at least I need to use it right now because I don't know chain rule and it's not going to factor out anyway. All right, here we go. So let's do it. How do I notate taking a derivative? dy dx. So we take the derivative of the top. So what's the derivative of the top? 5 times the bottom. So the bottom is x squared plus 1. And then minus. Now it's the derivative of the bottom. And so what's the derivative of the bottom? 2x times the top of 5x minus 2 all over x squared plus 1 quantity squared. All right, and so that was the calculus part, and that was not actually the hard part. The hard part's algebra, and we have to simplify. All right, and so what do we want to do with this 5? Distribute. So now I have 5x squared plus 5, and then I need to distribute this negative 2x, so now I have negative 10x squared, and then plus 4x, all over x squared plus 1 squared. All right, and so my dy dx is equal to, how many x squareds do I have? Negative 5x squared, and then plus 4x, and then plus 5, all over x squared plus 1 quantity squared. So there is my derivative of that function. And again, so we don't lose sight of it, what does that derivative actually mean? It's the slope of the tangent line of that original function. The quotient rule takes a little bit of time, and I try to avoid quotient rule whenever I can. And so I want to teach you some tricks on when you don't actually need quotient rule. So if this first one, it's a quotient, true? However, what's on the denominator? It's a 6. It's a monomial. All right? And so I could actually kind of like pull out a 1/6 or divide everything by 6, and then I can work with them separately. All right? And then we could take a derivative. So on this next one, I got 5x to the 4th over 8. And again, what could I pull out front with my constant multiple? More. I'd go 5/8. All right? Like you could okay? And so on this next one looks like you got to do quotient rule. However, you don't. Because what do all the terms have in them? An x. So what could it actually cancel out on all of them? An x. And so then what would the constant multiple be out front? A negative 3/7. And so then you'd take the negative 3/7, and then you'd still have the 3 minus 2x, and then we could differentiate from there. How would you think of this 9 over 5x squared?
9/5 times x to the negative second?
Exactly. All right. So you don't want to think of that as x squared. You want to think of that as x to the negative second, and then go from there. All right. And so a lot of the times, yes, things might look like a quotient, and you have to use quotient rule, but you can kind of manipulate them a little bit to make your life a little easier. All right. This is number 9 from your homework set. I am still going to assign this as number 9 because I want you to practice, even though we're going to do it right now. All right. So I want to teach you how to factor. And you guys, I'm really good at factoring. All right, so let's say we have like 1/3 x squared y minus, I don't know, 6, and then x y cubed. Let's say I wanted to factor this. All right, what could I factor out? I could factor out an x, I agree. What else? And a y. What else? I want to factor out a 1/3. All right? And then what am I left with?
X.
An x. And then minus, then what?
2.
It's not 2.
Sorry. Oh, it's negative.
I took out a 1/3 from a 6. What if I took out a 1/3 from a 1? Then it would be how many? 3. So if I took out a 1/3 from a 6, that's actually how much? That's 18. Okay? And then, if I factor out a y from a y cubed, I'd have what? Y squared. Okay? So let's kind of talk about what we just did, because now I'm going to put fractions and negatives on it in a sec. All right? So on here, we factor out an x, because which power was the least? Just the x to the power of 1, right? And I factored out just a y to the first because guess which power was my least? The y to the first. And what did we do to these powers? How did I get a y squared from a y cubed when I factored out a y? What did I do with it? I subtracted 1. Does everybody agree? All right? So now we're going to kind of use those algebra skills very soon. All right, let's take a derivative. Here we go. So we have h of x is equal to square root x over x cubed plus 1. What rule do I have to use because I have a binomial in the bottom? The quotient rule. So here we go. How do I notate taking a derivative?
H prime.
H prime. All right, so derivative of the top. So what's the derivative of the top?
Yes.
1/2 x to the what? Negative 1/2, because we subtracted a power, remember? And then times the what? The bottom. And so I have x cubed plus 1, and then minus, now I need to take the derivative of what? The bottom. And so what is the derivative of the bottom?
1x squared, 3x.
3x squared. and then times the top. And I'm just going to say this is x to the 1/2. Okay, it'll be easier for us to work with. All right, and then over the bottom what? Squared. So now I have this 1/2 and this 3. What do I factor out? A 1/2. Now I have this x to the negative 1/2 and this x to the 1/2. What can I factor out? X to the negative 1/2, because that's the least power. All right. And so now we're going to kind of like see what's left. All right. So if I factored out a 1/2 x to the negative 1/2 from this spot, then I'm left with what? 1. And then I still have this x cubed plus 1 minus, now I factored out a 1/2 from a 3. So what am I left with? 6. Very good. All right, so minus 6, and then I still have this x squared, and then I factored out a negative 1/2 power from a 1/2 power. So what happened? I subtracted them. So now it's x to the power of what? Not 0, but? Okay, if I factored out a y squared from a y cubed, what did I do to it? I subtracted. So now I take 1/2 and I subtract negative 1/2, which is how much? 1. It's 2/2, all right? Because I'm really subtracting a negative. And so this is really x to the power of 1. And that's really the whole reason behind why we do it. And we'll do it more, all right? Maybe not today, but we'll do it more. All right, and so then we have x cubed plus 1 squared. All right, so now let's simplify it, because we got to keep simplifying. So if I have 1/2, does everybody agree that the 2 goes in the denominator? Cool. This is my childhood, so guess where that goes? That goes to the basement. And so then that would be x to the what? So we have square root x. I'm fine with that. And then we'd have x cubed plus 1 squared still. All right. And so now we just need to simplify this numerator. And so if I distribute this 1, I still have x cubed plus 1. Everybody agree? Yes. And then minus how much? 6x cubed. So how many x cubes do we have? Negative 5x cubed. Lovely. And then plus 1. And so h prime of x was equal to this negative 5x cubed plus 1 over 2 square root x times the quantity x cubed plus 1 squared. All right. All right, so this is very similar to 59 from your homework last night or the weekend. We are trying to find a horizontal tangent line. We're trying to find the points of horizontal tangency. All right. So what do we need for a horizontal tangent line? I need to set what equal to 0? My derivative equal to 0. Exactly. So what do we have to use again?
There's a binomial, so I think we have to use the quotient.
We have to use the quotient rule. Okay. We don't have another way. All right. So how do I notate taking a derivative? F prime of x. All right. So how do we take a derivative? Derivative of the what? The top. What's the derivative of the top? 2x times x squared plus 1. And then minus the derivative of the bottom. What is the derivative of the bottom? 2x. And then times x squared, the top. All over. Love it. All right. And so there's my raw derivative. Now we just have to simplify it up a little bit. All right. And so what do we do with this 2x? We distribute it. So what do we end up getting?
2x cubed plus 2x.
And then
X cubed.
minus 2x cubed. All over x squared plus 1 squared. Does anything lovely happen?
Yes. 2x cubed.
Love that. All right. And so then f prime is equal to 2x over x squared plus 1 quantity squared. All right, and what do we want to do with that? If I need to find a horizontal tangent line, what do I want to do with that? I want to set that equal to 0. So when I solve for this, what happens to my denominator? I multiply by it, but 0 times the denominator is going to be what? 0. And so I basically have 2x equals 0. What does x equal? 0. X equals 0 of where my x value is horizontal tangent, but what did it ask for? A point. So how do we find a point?
Looks like we have to substitute
we substitute it back in. So we set 0 in for x, so f of 0. When I substitute in 0, what do I get in my numerator? 0. What do I get in my denominator? 1, so I end up with 0. So my point is 0, 0 is my horizontal tangent. A little bit of practice. All right.